Hello, everybody. I hope all of you are doing great. Welcome back to my YouTube channel, Computing Academy, and welcome back to another video as well. In this video, I'm going to talk about CPU architecture. So, you have to stay connected with me to get complete information about it. Now, let's come to our today's video's topic. But before I start, you have to press the bell icon and subscribe to my YouTube channel to get complete information about my upcoming videos. Now let's discuss the CPU architecture in detail. First of all, we will talk about trap, different types of traps, and many other details as well. So first of all, let's talk about what is trap. When CPU is running in user mode, some internal or external events which need to be handled in kernel mode take place. Then what CPU does? CPU will jump to hardware exemption handler vector and execute system operations in kernel mode. So this was basic definition, or you can say basic information about the trap. Now we have the different trap types. So let's have a look at the different types of trap in detail. And these different types include system call, hardware interrupts, and exception. Let's talk about system call. It is invoked by application in user mode. For example, application asks operating system for system I/O. Then we have hardware interrupts. These are invoked by some hardware events in any mode. For example, hardware clock, timer, trigger, event. Then we have exception, and it is invoked when unaccepted error or system malfunction occurs. For example, execute privilege instructions in user mode. So these were the basic types of trap, which include system call, hardware interrupts, and exception. Then we have to talk about trap and emulate model. If we want CPU virtualization to be efficient, how should we implement the VMM? So here is the answer to this confusion. We should make guest binaries run on CPU as fast as possible. And theoretically speaking, if we can run all guest binaries natively, there will be no overhead at all. But we cannot let guest OS handle everything. VMM should be able to control all hardware resources. And what is the solution to this problem? The solution is provided here. And the solution is ring compression. Shift traditional OS from kernel mode to user mode and run VMM in kernel mode. Then what you have to do is then VMM will be able to intercept all trapping event. This was the basic solution. And now VMM virtualization paradigm, which is trap and emulate. Let normal instructions of guest OS run directly on processor in user mode. And when executing privilege instructions, hardware will make processor trap into the VMM. The VMM emulates the effect of the privilege instructions for the guest OS and return to guest. You can also see the diagram here. This is here. Then we have traditional OS and all the details. When application invoke a system call, when hardware event and details are further provided here. Then we have VMM and guest OS, which involves system call, hardware interrupt, and privilege instruction. System call includes CPU will trap into interrupt handler vector of VMM and VMM jump back into guest OS. If we talk about hardware interrupt, hardware makes CPU trap to interrupt handler of VMM, and VMM jump to corresponding interrupt handler of guest OS. And the last one is privilege instruction. Running privilege instructions in guest OS will be trapped to VMM for instruction emulation. And after emulation, VMM jump back to guest OS. So this was all for today's video. Hope you will like it, and if you like it, do share it with others as well. And don't forget to like and subscribe to my YouTube channel for my upcoming videos. Take care everybody.